All right, hi everybody. I am going to jump into kind of the rest of Unit 1 stuff today. I know that it was really fast to get through Unit 1, but it should mostly be review. Some of the stuff that you might see today is a little bit new, but I think you're going to be able to handle it. I wanted to just kind of communicate what I was going to do about the learning targets for this unit. What you saw yesterday, I'm going to wrap all into learning targets 1A and 1B, and then the stuff from today is in 1C. So there are 3 learning targets going into Skyward this time around. I know that yesterday I kind of had 5 listed out, but today I'm going to just show that there are 3 going on. Really what we're focusing on today is inequalities with one variable. We're going to look at some compound inequalities today. Then we're also going to look at absolute value equations and inequalities. So that might be somewhat new, but I think you'll be able to catch on. Okay, a compound inequality has more than one inequality at the same time, and it's really critical to see if it says and or if it says or. If it says and, it means that both inequalities have to be true at the same time, and if it says or, then only one of them can be true at the same time, or one of them can be true. If both of them are true, then it doesn't work. So here we go. I'm just going to do a little sketching here so that we can talk about what these look like. Here is where x is 5. So here's where 5 is. And -4 is over here somewhere. There's some number line going on here. X is less than 5 looks like that. This is x is less than 5. And then this one is x is greater than or equal to -4. And that goes all the way, I'm going to do that again, all the way over here. Okay, so what is the part of this graph that has both things being true? They're both true right here. They're both true all the way through here. And then all of a sudden they're not true anymore. So right here, there's an empty spot because that's not the black inequality isn't a true inequality anymore. So my answer here looks like this. Okay, so there's an open circle at 5 and there's a closed circle at -4. These are all of the places where it's true for both inequalities, so both have to be true. I'm going to do the same thing over here. Here is where 4 is, and here's where 7 is, or so. Doesn't really matter, I'm just trying to draw some stuff. X is less than 4 over here. X is greater than or equal to 7, like that. Okay, so where is it true that one or the other, but not both at the same time are true? Well, it's all of this. So my answer looks like this. Okay, so I know that's a little bit weird, but I can basically put together these inequalities, figure out where both are true or where one or the other is true, depending on what it says to do. And then that's kind of how you get your answer. Okay, so I'm going to just do a couple examples here, and then I'll probably have some for you to practice. Okay, so let's solve for x here. So I'm going to divide both sides by -2. Whoa! What happens when I divide by -2? I get, okay, 3x plus 6 on this side. But remember, when you divide by a negative number, that inequality has to reverse directions. So we have to write is greater than or equal to, whoopsies, is greater than or equal to -21 now. Okay, and then I need to get x by itself. So subtract 6 minus 6. I get 3x is greater than or equal to -27. Divide both sides by 3. And I get x is greater than or equal to -9. Okay, so that's one part. There's still this and here, so I got to do that. So I'm going to subtract 6, subtract 6. It says x is less than -2. Okay, so I'm going to sketch now. Here's my perfect number line. Here is where -9 is. And here is where -2 is. So then 0 would be like right here-ish. Okay, so it says x is less than 2, and x is greater than or equal to 9. Okay, so where is it true that both inequalities are true? Because this says and, so I have to have both are true. So where is it true that they're both true? Okay, so right here, all the way to here, and then you just kind of connect those. Usually ands point towards each other, and ors point away from each other, but that's not always the case, so be careful. Okay, next one. I think you're kind of getting it, so I'm going to just do this one quickly, and then we'll move on with our lives. So minus 1, I get 6 is less than 2x. Divide by 2, I get 3 is less than x. Okay, remember that you could also write this as x is greater than 3. These two things mean exactly the same, and I'm more comfortable with it saying x is greater than 3 than I am with 3 is less than x. So up to you. Divide both sides by 3 over here. I get x is less than or equal to 6. So very similar to what we had on the last one. Here's my number line. Here's where 3 is. Here's where 6 is. 0's over here then. So x is greater than 3 is that inequality. X is less than or equal to 6 is this inequality. So where are they both true? They are both true during this part of the graph. Like that. Just kidding, this has to get filled in. Okay, there we go. Okay, this one is an or, which means one or the other, but not both. So let's solve for k here. So I need to subtract 7. Whoops, 7, subtract 7. So then I get k is greater than or equal to -1. And then I have this one, which is, okay, so I'm going to subtract 8, subtract 8. And so I get k is less than -5. Okay, so here's my number line. Here's where 0 is. Here's where -1 is. And here's where -5 is. Or something. Okay, so it says k is less than -5. And it says k is greater than or equal to -1. This is my answer because there's no place, I can't make any line where both are true. It doesn't work to get both of them to be true. So this is my final answer here. You might get some that are overlapping, and then we have to deal with a little bit of weirdness, but for now, let's call that good. I am going to ask you to do some of your textbook problems today, and so you actually need to open up the Algebra 2 textbook by going to the classwork tab, and then there's this link right here. You can open up this assignment, and then you can access the PDF of the textbook. Here are the problems I want you to complete, and yes, it is totally fine if you use Slater to check your work. I don't really mind as long as you're not looking at Slater to get it done the first time. I don't mind if you look at it to check your work. That's totally fine. Okay, now we're kind of in the absolute value part of this inequalities lesson. So I'm going to start talking about what absolute value is in a second, and then we'll start doing some inequalities with it and some equations. Okay. Hopefully you have seen absolute value before. Everywhere I see an x, I'm going to put a -4 in. So I get -4 plus -4 plus absolute value of 3 times -4 minus 7. Now this is an order of operations problem, and I will just tell you that these absolute value bars are a grouping symbol. So they work a little bit like parentheses, but they also do a special thing. So 3 times -4 is -12. -12 minus 7 is -19. All right. Then I'm just going to rewrite. Wait, -4 plus -4 is -8. Okay. The absolute value of -19. This means how far away from 0 is negative 19? The answer is 19 units. Okay, so the absolute value of negative 19 is 19. So I'm going to rewrite over here, negative 8 plus 19. Negative 8 plus 19 is 11. There's my answer. Okay, so really we have to define absolute value as the distance a number is from 0. Distances are always a positive number. You can't go negative 7 miles. That doesn't make sense. So when we talk about distance from 0, it's got to be a positive number. Really what it says is take that absolute value, whatever's inside the absolute value, and just make sure that it's positive. So if it's the absolute value of negative 4 is 4, but the absolute value of 4 is also 4. Both sides. Okay, so let's decode what this actually is saying then, this equation. This equation is saying like, okay, hey, the distance from 0 of this stuff that I just underlined is 12. So 2x plus 6 is 12 units away from 0. What are the options? So I'm going to actually draw a little number line here so that we can kind of visualize this a little bit. Okay, this is where 0 is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is where 2x plus 6 could be. But also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2x plus 6 could also be right here. So let's just count this off. This would have been negative 12, and this would have been 12. So I can actually take this information that I got from my equation. It said 2x plus 6 is 12 units away from 0. And I can use that to create my number line and look at it visually. But then I can set up two equations. This equation says 2x plus 6 is equal to negative 12. And this equation says 2x plus 6 is equal to positive 12. Okay, so then I need to do two-step equations to solve these. So just subtract 6, I get, careful, 2x is negative 18. Divide both sides by 2. And I get x is negative 9. So there's one answer. But then I also have to do it over here. So subtract 6. I get 2x equals 6 by 2. And I get x is 3. Okay, so I got two answers here, and I don't believe myself yet. So I want to just check. I'm going to do this mentally. I'm just going to take these two answers and put them back in for x and make sure that it works. So take the negative 9. 2 times negative 9 is negative 18. That's this part. Negative 18 plus 6 is negative 12. The absolute value of negative 12 is 12. That works. Okay. 3 times 2 is 6. 6 plus 6 is 12. The absolute value of 12 is 12. So that works also. So we have two answers here. That's weird. Okay. Similar thing here, but this one's a little bit weird because now we have to apply that concept of what absolute value means, but make it work with our algebra. So remember when I said, okay, this thing really gives me two answers. It gives me 2x. It gives me 2x minus 6 is equal to two things. It gave me a positive and it gave me a negative. And the things that were underlined were what was on the other side of this equation. So I'm going to take this stuff and put it here and here. and rewrite. And then we're going to have two equations that we have to solve. So I'm going to rewrite 2x minus 6 is equal to x plus 4 was the first one. And then the other one was 2x minus 6 is equal to the negative version, x plus 4. You can take this negative and distribute it through here. That's fine. So then we would end up with that. Okay, these are both equations that you know how to solve. You will get answers when you finish this problem. I'm not going to finish this problem right now, but the one thing I need to say is check your work at the end by putting in your x equals back into, take this stuff and put it back into your equation here and here and make sure that it works. If it doesn't work, then you did something wrong, or you have something called extraneous solution. Sorry, I had to skip through a couple slides here. I just wanted to skip some things because that's plenty of information here. So extraneous solutions happen sometimes, and what that means is you do something with your algebra that creates a mistake, and you have to check for that mistake at the end. It's not that you did something wrong, but it creates an extra thing going on. So I'm going to give you an example of that here. Normally what we would do 3x plus 2 equals 4x plus 5. We would do that. And we would do 3x plus 2 equals negative 4x plus 5. Okay, so let's simplify. I'm going to subtract 3 from x from both sides. And I get 2 equals x plus 5. Subtract 5 from both sides, and I get x is negative 3. I'm going to do exactly the same thing over here, except I'm going to start by distributing the negative through here and here. So I'm going to rewrite as 3x plus 2 equals negative 4x minus 5. Okay. Add, this time, 4x to both sides. And I get 7x plus 2 equals negative 5. Then I'm going to subtract 2, and I get 7x equals negative 7. Divide both sides by 7, and I get x is negative 1. Okay, now I'm going to take these two answers, put them back into my original equation, and see if they work. So I'm going to talk through this. I'm going to take the x is negative 3, put it here and here. Okay, negative 3 times 3 is negative 9. Negative 9 plus 2 is negative 7. The absolute value of this side is 7. So over here I get 7. I'm just going to record that so that I remember. Over here I get negative 3 times 4 is negative 12. Plus 5 is, negative. Hold on, I have an equation now that says 7 equals negative 7. No, it's not. It's not equal. And so this means that this is an extraneous solution. I'm going to have you check this negative 1 answer. I want you to see if that one's extraneous or not. Okay. The very last thing that we're going to do today is we're going to talk about some inequalities. And again, we have to kind of go back to what absolute value means. So the first thing I'm going to do, and the first thing you should always do on these types of problems, is get the absolute value by itself. So that means I'm going to divide both sides by 7. And so then I get the absolute value of 1/3 x plus 4 is greater than or equal to 6. What does this mean? Okay, this says the distance from 0. Okay, so 1/3 x plus 4 is at least 6 units away from 0. Okay, so it could be, wait, let me draw a little diagram then. Here's where 0 is. Here's where 6 is. Here's where -6 is. This inequality says my answer 1/3 x plus 4 has to give me this inequality. So what that says is, this one says 1/3 x plus 4 is less than or equal to -6. And this one over here says 1/3 x plus 4 is at least 6. So then from there, I can solve for x in these inequalities and get x by itself. And then from there, I can kind of come up with my answer. So -4. I'm going to do both of these kind of at the same time because the steps are going to be the same. So subtract 4 on this side, I get 1/3 of an x is greater than or equal to 2. Over here, I get 1/3 of an x is less than or equal to -10. Then I have to multiply both sides by 3 to get rid of this. So then I get x is less than or equal to -30, and x is greater than or equal to 6. So now I have my two answers. Here's my new number line. Here's where -30 is. Here's where 0 is. Here's where 6 is. So x is at least 6. X is greater than or equal to 6. And x is less than or equal to -30. Okay, so I used this method up here. I used this thing right here to think about what does this absolute value expression right here mean? And it means that it's at least 6 units away from 0. What that creates is all of this stuff. It creates two inequalities that I have to solve for x, and then I have to graph those at the end. Last problem, I'm just going to do this very similarly to how I did the last one. So divide both sides by 4. And now I get the absolute value of 2x minus 15 is less than or equal to 7. What that means is, here's my number line. Here's where 0 is. What it says is this 2x minus 15, the distance from 0 is less than or equal to 7. So here's where 7 is. Here's where -7 is. So my 2x minus 15, it has to be within this area because the distance from 0 to 2x minus 15 has to be less than or equal to 7. So what that means is 2x minus 15 is less than or equal to 7. That one works, but then I also have to do 2x minus 15 is greater than or equal to -7. Okay, so again, I'm going to have you solve these inequalities, get x by itself, and then from there you can graph your final answer. You can finish this one up for yourself. Should have gotten x is less than or equal to 11 on this side, and x is greater than or equal to 4. So on my number line, here's where 0 is, here's where 4 is, and here's where 11 is. So x is less than or equal to 11, but x is also greater than or equal to 4. So that and inequality is all of this right there. So there's my answer. All you have left to do is finish the mastery check, and then we are officially done with Unit 1. Have a good day, and I'll see you next lesson.